And good morning. So area of triangles using determinants. We are going to follow the directions in page 204 in your books. Whether you're online or physically looking at it, you probably want to do that. Page 204 is where you'll find it. So we're going to look at that example and how to find the area of triangles using what we learned last week about determinants. Oh man, everybody give me a oh sweet mama, please give me a 2 by 2.
Oh, sweet mama, please give me a 2 by 2.
Because those matrices are much easier to find the determinant, right? And much faster. Well, with area, we have to build a 3 by 3. Give me a, oh. Yeah, so 3 by 3 is what we're going to be building today. But how do we build it? So what we're going to look at in example 3, and by the way, this is something we're going to be asking you, Mr. Barber and I, tomorrow. You'll be going out in the courtyard and finding triangles that exist on campus and using what I'm showing you today to estimate the area of those triangles. So it requires you to have a triangle that you have sitting on a coordinate grid. So if you're looking at page 204, you see that there is a triangle there, positioned sort of like this. And what they've done is given you variables that represent those coordinates, so it can be any triangle in the universe that you find tomorrow on campus. All you need to do is find the vertices, the coordinates of the vertices. Now, if you're walking around out in the real world, you see a coordinate grid sitting out there. If you do, we'll get you some psychological help and you'll be okay. But out in the real world, you really don't see coordinate grids. So what you're going to have to do tomorrow is build your coordinate. Once you find the triangle, you have to establish one of them. I have to find the coordinates of each of those vertices. It's only two-dimensional. We're talking about two-dimensional shapes today and tomorrow. So you don't have to find 3 coordinates. All you have to find are 2. 2 coordinates for the 3 corners, the 3 vertices of a particular triangle. How many vertices will a triangle ever have? 3. Yeah, if it's a triangle, you got 3 of them, right? So you're going to have to find all 3 of them and give them coordinate locations of all the corners. Once you've done that, then what you can do is use this formula. Now, if you go back to elementary school and somebody said, hey, what's the formula for the area of a triangle, you would respond?
Length.
1/2 base times height, which Austin said incredibly well. That's how you find the area of any triangle. You have to have the length of the base and the length of the height, and you divide that by 2 or multiply by 1/2, and you have the area of that triangle. That's from elementary school to middle school. Now we're in high school, we're studying matrices, so I'm showing you how to use that to find another way of determining or estimating the area. Well, lo and behold, it again has a half in it. Like Austin said, 1/2 base times height. This formula using the determinant has a half, but you see the symbols in front of it, plus and minus. That means that we are going to we're going to multiply by either positive 1/2 or negative 1/2, depending on what the determinant of the matrix is that we get. Because out in our real world, if you find a triangle tomorrow on campus, to estimate the area of, would it ever be a negative area? No. Not in our world. Doesn't make sense. It'll always be positive. So if this determinant that we're going to build in just a second, if that determinant's negative, am I going to multiply by positive or negative? Negative. That way the area will be a positive area. But
if there was a negative area, how would that work?
That's a very interesting question for another topic in time. How would the negative area, what would that look like? See, we don't understand that. We can't wrap our minds around that physically. We can represent that mathematically. But in our 3-dimensional world, we have a conversation and a debate, a Socratic seminar conversation on what that might look like. David?
But if you're having negative area, wouldn't that just be no area? So it'd be nothing?
Well, no, negative would mean it's actually less than nothing. What does that mean? It's hard for us to understand and wrap our mind around it. It's a wormhole. It may be a black hole. Maybe some of that conversation would go to that. The negative universe. We talk about parallel universes. Maybe that's where we find negative area. We don't know. But we can have a conversation about that. So we're going to multiply by the positive or negative 1/2. And if you remember from last week, we saw vertical lines, parallel lines on either side of a matrix. It was subtle, but you learned that this wasn't the matrix symbol, which are brackets typically. This was asking you to do what? When you see parallel lines on either side, it means to do what? Find the determinant, which we learned last week, Wednesday. Kelsey, you were gone. How to do that. Okay? So what we're going to build here is a 3 by 3 matrix. Everybody give me a because finding the determinant of the 3 by 3 is much more arduous and difficult than the 2 by 2. So matrix of 3 by 3. How do we build this? What numbers do we put in there? If you look at the book, it gives you sort of a pattern. What I want you to think about is this is a 3 by 3. These 3 columns represent the 3 different things. The first column represents the x coordinates of the vertices. This is the x column. This is the y column. And the last column is the 1 column. We're always going to put 1s in that third column. But we need to put the x and y's, the corners, the vertices, the coordinates of where our triangle is, by in the first and second column. So I'm going to put the x's in that first column, the x coordinates of the corners, the vertices. Now it doesn't matter what order you put the x's, but once you do that, you must always pair up the y coordinate with that x. So what y coordinate goes with the x1 coordinate? y1. So you must pair those up correctly. Again, when you're looking out in the real world at your triangles, it doesn't matter which coordinate you put first. Just make sure you match up the coordinates with the vertices. Okay? So that's our 3 by 3. For Kelsey's sake, I'll refresh our memory on how we determine the determinant of this 3 by 3 matrix. Can anybody recall from last Wednesday? Yes.
Well, you have to put the first 2 columns again on the outside.
That's right. So we're going to make this, we're going to build 2 more columns to the right-hand side. We're just going to rewrite the first and second column. Whatever they are, you're just going to copy them down. So now I have a 4th and 5th column. Okay? That's the first thing you do. Now, what was this next thing we did last week? Do you recall? What do you do?
What we did last week?
Yeah. Got to find the determinant. What did we do last week?
The diagonal.
Oh,
The
diagonal what?
multiplying.
Multiplication. Thank you, Frank. So we're going to start in the upper left-hand corner, and we're just going to, if it helps you, draw diagonal lines. I'm doing it now for a visual, for Kelsey's sake and for Mary's. I don't think Mary's here either. Those 3 numbers written in diagonals like that, we're going to do what with them, Frankie?
Multiplying.
We're going to multiply them all together. And then, am I going to add those, or am I going to subtract those? I'm going to add them because they're going in that direction. So, also then, once I've multiplied all those, I'm going to start in the upper right-hand corner, and again, draw diagonals. I'm doing it in a different color, and it's going in a different direction. Connecting those 3 numbers together, and what am I going to do with those?
You're going to multiply.
I always multiply them again, but once
Subtract
I multiply them, do I add them or subtract them?
Subtract.
I subtract them, which again, for the video's sake, when you back this back and forward and hear this a number of times, subtracting is adding the opposite. So when I multiply these numbers and get a positive number, I'm just going to subtract that positive number, or add the negative. If I multiply these numbers and get a negative number, then I'm going to subtract that negative number, which is the same thing as adding positive. Okay, so I can always use the adding rule. Not have to learn another. If the signs are the same, you add and stay. If the signs are different, you got to subtract, keep the sign of argument. So those are the only rules I need to have. So again, like Mr. Barber says, if you come to us in high school, from elementary school and middle school, with these skills, all you really have to do to step into an algebra class, for us to be confident we can teach you, is add, subtract, multiply, and divide. If you can come to us in high school and be able to add, subtract, multiply, and divide out of 8 years of math history, 8 years of math practice, kindergarten through 8th grade, maybe that's 9 years. Out of that experience, if you can add, subtract, multiply, and divide, we can teach you algebra. Because all we're going to be doing today is add, subtracting, multiplying, and dividing. That's it. I'm just showing you in a different way, some way you've never seen before, how to set something up in a matrix configuration, how to find the determinant, and then use it to find the area. Okay? David?
The black lines, are you adding those?
Good question. Can anybody answer?
You're adding the black lines.
The black lines, what am I doing?
They're multiplying.
I'm multiplying those diagonals. All the numbers in the diagonals I multiply. If the diagonals are going this direction, black, here on the board, do I add or subtract that multiplied number?
Add.
I add them. If they're going the other direction, do I add or subtract?
Subtract.
Subtract. Just to repeat. Okay, good question, David. All right, so that is how we learn how to do determinants of a 3 by 3. 2 by 2s, we'll see in a minute, much easier. But that is how we find the area. We're going to find the determinant of that 3 by 3. Do you understand how to build it? And then we divide it by 2, or multiply it by 1/2. If the final answer is positive, what am I going to do with that? Make it negative, right? Because I can't have negative area. This determinant, once you crunch the numbers, it might be negative, right? From last week's experience.
Yes.
If it's negative, when I divide it by 2, what am I going to do with that final answer? Can I have negative area?
No.
Can't. I'll just make it positive.
Oh.
Just make it positive. That's what happens when you multiply by a negative, just make it positive. Right? If it's already positive, let it stay positive. Right? Just make sure the area is what?
Positive.
Positive when you end up with it after dividing by 2. So that's how we're going to practice this. There's an example that they use in the book. You can follow it. I'm going to go to this second lesson that I'm sharing with you today, and that is how to use what they call the Kramer's rule, which helps you find a solution to a system. Now, when you did business consultant projects, when you did those presentations, you used elimination or substitution or something to find where 2 lines crossed, right? Today I'm showing you another method using matrices. It's called Kramer's rule. These guys have been given credit for this. So if you'll look now on page 205, at the top of that, you see an example of the rule itself. What I want to do with this example is just show you a real situation. So example 3. If you look at example 3, they give you 2 equations. 9x plus 4y equals -6. 3x minus 5y equals -21. Those 2 equations together we call a system. If you didn't know Kramer's rule, which you don't, if you were asked to solve this on an ACT or in the chapter test you just got through with, or doing the presentation of business consultants, what would you do? What method would you use? Probably elimination. Okay? You would probably want to use elimination so you wouldn't have to deal with fractions. And that's exactly what you could do. I'm going to show you a different method, which, as I'm showing it to you, you may think, my God, why would I do that? Because it takes so long. But me showing you takes a long time. Once you do this a couple of times, you'll see that it's probably a faster way of doing it. Jordan, did you have a question?
This would be the third.
Third method, very good. Well, fourth if you count graphing. Okay? So we've got this system. Here's how you use matrices and the determinants of those to find that solution. Again, finding the solution means I want to find the x and y coordinate where they cross. What's the x coordinate? Where's the y coordinate that these 2 lines cross? That's what we're talking about. So here's what we do. The first thing you do is build what they call a coefficient matrix. Now we're just going to deal with 2 by 2s. Yes. Everybody give me a, oh yeah. Oh yeah. Because the 2 by 2 determinants are much easier to find. So the coefficient matrix is the first matrix we're going to build, and then we're going to find the determinant of that. The phrase coefficient means the number in front of the variables, right? So here I've got how many x's? 9. That's what we call as a coefficient. So again, just like over here with the formula, I'm going to have an x column and a y column. So I'm going to put the x coefficients in the first column and the y coefficients in the second. Okay? Here's another subtle thing for Kelsey and Mary. This is a matrix because I have brackets around them, right? If you wanted to ask somebody to find the determinant, what would you have around these numbers? Just vertical lines. That communicates, hey, find the determinant of that 2 by 2 matrix, 2 rows and 2 columns, right? 2 by 2 is much easier. All you do is, again, cross multiply. You do diagonals again, but you only have 2 sets to do. So you're going to cross multiply, and in this direction, are you going to add or subtract? If that direction, you're going to add or subtract. So this gets you a negative 45. If I multiply right, all you have to do is multiply and subtract. If I multiply that correctly, that's negative 45. If I multiply this correctly, what do I get?
Negative 12.
Positive 12, and I want to subtract that because it's going that direction. Whatever that number is, I'm going to subtract. Again, Stevenson would say, hey, don't subtract anything. Add opposite. So let's make that negative 12. Signs are the same now. Use the adding rule. I add and stay negative, right? So that's the determinant for that coefficient matrix. Okay?
Okay.
We need to find 2 more determinants. But the first thing I have to do is show you how to build it. So I want you to look at the example.
So that's x plot.
Sorry? No. That's the determinant of the coefficient matrix. Okay? Coefficient matrix, find the determinant. Now we're going to build 2 more matrices, both 2 by 2 in size, and calculate the determinants of each. Here's how you build the matrices. I'm just going to write the numbers down. If you're going to find the x coordinates, this is answering Cole's question. Here's how you find the x thing to put right here. Here's how you do it. You're going to build another 2 by 2 matrix. This is how. I'm just going to write the numbers down, and you tell me, you write the rule. Let me write the numbers down for the x coordinate for this example, and you tell me a rule so that you can follow it every single time. That's the matrix we want to find a determinant of. Look at the pattern of numbers that you see written, and you tell me the rule. Kramer got credit for it. Let's make it the Jordan rule. Let's make it the Austin rule. Let's make it the Elijah rule. Let's make it the Sarah rule. You tell me the rule. Looking at the pattern of the numbers and how they're written. To find the x coordinate of a solution, how are you going to build that matrix? How are you going to build that 2 by 2? See where the numbers are. Find the pattern.
I'm kind of confused on what you want.
I want you to write a rule. You see me where I've written the numbers and how they're different than the first one? You see the system? Look at what numbers I put here to discover your rule. Not Kramer's, you write the rule. Sarah.
You kept the y, but then you used the...
You did what? Say it again.
You kept the y.
You kept the y's. Oh, notice the y coordinates are exactly the same as the coefficient matrix. But then what did we not keep?
You didn't keep the x's.
Didn't keep the x's, but what did we write? What numbers did we write instead of the x numbers? What numbers did we write?
Oh. Numbers that they were both.
Oh, the answer's in the equations, right? The negative 6 and the negative 21 in the same order, right? I had 9 here in this first equation, so I don't write 9, I write negative 6. I had 3 in the second equation, right? But I didn't write 3, I wrote negative 21 in that second equation. So however you want to write that, I want it to be your rule, wrap your mind around it. I'll repeat it the way I would say it. To find the x coordinate, I don't write the x column. I substitute in the answer column, if you want to call it that. Keep the y's. Substitute the x column with the answer. Now I've got a 2 by 2. Can you find the determinant of that? Sure. What am I going to do with 6 and 5? I'm going to multiply negative 6 and negative 5, and what do you get? Positive. I'm going to multiply 4 and 21 and get negative 84. But I'm going to subtract that. So now the next, so that's a determinant, right? 114. To find the x-coordinate, you take the determinant of this 2 by 2 and divide it by the determinant of the coefficient.
This is so not faster.
It isn't now because I'm taking the time to show it to you. Once you've done this a couple of times, it'll be radically faster. Where did I get 57? Where did I get 57?
Because you got 40.
Where did I get negative 57?
You got negative 45
Oh,
and
that's the
negative 12.
determinant of the coefficient matrix, which I said you take this determinant and divide it by the coefficient matrix determinant. Defining those numbers, I think the book tells you it's what?
Wait, isn't it positive 57 though?
No, it's negative.
Oh, okay. Because I thought you said to keep it a positive.
Don't confuse the rules. Whatever number you end up with, don't confuse finding the area rule to this. We're not finding the area now. I'm showing you the second thing. 2 lessons today, finding the area. Now we're doing a different lesson. Don't use the same things for both.
So is negative 2 x?
That's right. So negative 2 is the x-coordinate of the solution. Taking the determinant of this matrix that you now know how to build and dividing it by the determinant of the coefficient matrix, which we calculated first. So now that you've kind of seen that rule, kind of know your rule, find the x, how would you find the y?
You subtract
Keep the x's.
2.
Keep the x's, Austin's saying, but what are you going to write for the y's?
The answers.
Negative 6 and negative 2. The answer. So I'm going to make a matrix. I'm going to keep the x's, like Austin said so incredibly well, but instead of the y's, because I'm finding the y's now, I'm going to write what? Negative 6 and negative 21. So all I'm going to do again is build that 2 by 2, which finding the determinants of that is much faster, right? Much easier, much quicker. But again, I'm going to divide that by negative 57 because that's the coefficient matrix determinant. Again, finding this 2 by 2, Kelsey's getting lots of practice here. What am I going to do with 9 and negative 2?
Negative 18.
Negative 18, am I adding that? Yeah, I'm not changing the sign of that. What about 3 and negative 6?
Negative 18.
And I'm going to subtract that though, so instead of negative 18, it's going to be positive 18 that I'm adding. Whoops.
Yeah.
You put a 2 instead of 2.
Oh, thank you. 9 and 21. 9 paired with 1 and 18. But it's also still going to be negative, so I'm going to add 9 times 21, 18 and 9, right?
189.
And the signs are different there, so I use the adding rule, subtract the sign of the larger one. So the term of that, again, they give you the answer, 171. The bigger one's negative, divided by negative 57, I get positive 3. And that's the y-coordinate of that particular method. Here is a fourth method of finding the solution to a system. You're going to practice these problems to get better at it. We are the Ask Academy.